In this lecture, we'll take a look at the computer system and discuss the components that make up that system. Previously, we introduced the elementary building blocks of computer systems. We've talked about gates, logic circuits. We even talked a little bit about transistors, and that's great and all. And so, I mean, this stuff is essential to understanding computer hardware, but we're only looking at the computer system at a very, very low level. So, I mean, it still doesn't really help us answer the question, how do computers actually work? So instead, we need to see how we can use these gates and circuits to put together more complex stuff. So looking at a more high-level approach. And this is what we call functional units. So what we're doing is we're going to take the gates and the circuits, we're going to combine them together and construct these higher level units called functional units. And the idea with these units is they can handle different types of tasks. So they can do things such as instruction processing, information storage, computation, and data transfer. In fact, the branch of computer science that studies computers in terms of the major functional units is what we call computer organization. And this is what we're going to be focusing on for a little while. So here, we're not going to be looking at systems in terms of gates and circuits, but instead, we're going to be looking at functional units as these higher level abstractions, and they'll give us a much better understanding of how a computer actually works. We'll start by taking a look at the components of a computer system. There are a huge number of computer systems on the market, and these are all manufactured by dozens of different types of vendors. We're talking about multi-million-dollar supercomputers, we're talking about million-dollar mainframes, mid-sized systems, workstations, laptops, tablets, smartphones that even cost less than $100. And along with the size and the cost, computers also differ in speed, memory capacity, input-output capabilities, and the software that's available. I mean, the hardware marketplace is very diverse and it's always changing. Yet with all that said, even with all these differences, I should say, with these systems, virtually every computer that's used today is based on the same design. I mean, you may think that $1 million mainframe and a $1,000 laptop or a $100 smartphone don't really have a whole lot in common, but they are all based on the same fundamental principles. And this design is what we call the von Neumann architecture. And we talked a little bit about the guy who made this before. His name was John von Neumann. He proposed this in 1946, and he was a brilliant mathematician that came up with this model. So now we're going to actually get into the details of what this model is all about. The von Neumann architecture is based on the following three characteristics. The first one is that we have four major subsystems, and we call these the memory, the input-output, the arithmetic or logic unit, also known as the ALU, and the control unit. It's worth noting that the ALU and the control unit are often bundled together in what we call the central processing unit, or the CPU. The second characteristic is what's called the stored program concept. Here we have the instructions being executed by the computer, and these instructions are represented as binary values and stored in our memory. The third characteristic is that we have the sequential execution of instructions. So what does that mean? We're saying that one instruction at a time is fetched from memory and passed to the control unit, where then the instruction is decoded and executed.